Welcome, everyone, to a deep dive that might just challenge everything you thought you knew about, well, everything. The universe, basically.
It's pretty mind-bending stuff today.
And we're digging into this piece called, Hey, Science Community, You're in a Motion-Based Universe? You're welcome. Quite the title.
Definitely makes a statement.
And our mission, really, is to unpack its core idea. What if motion, just simple movement, is the fundamental reality? Not time, not particles, just motion.
It sounds almost too simple, doesn't it?
It does. Like, what if all the complexity we see is just, different patterns of motion?
And what's really fascinating here is how the source argues that science has been sort of dancing around this idea without naming it. It's not saying throw out physics, not at all. But it's proposing this single underlying substrate, motion.
A unifying principle.
Exactly. A clean structural way to look at, well, the whole cosmos.
Okay, so let's get right to that core claim. It's super direct. Motion is the fundamental, not time, not forces, not particles, just motion.
No hidden stuff, no magic bits.
Right. No tiny billiard balls called mass. Instead, it says everything we study is just motion looping, sinking, adapting, collapsing, and stabilizing across scales.
So the idea is, instead of looking for smaller and smaller pieces,
Yeah.
we should see that motion itself is the irreducible thing. It can't be broken down further. The source kind of points out, look, science talks about motion constantly. Equations of motion, right? Problem solving is often just rearranging motion variables.
But we never asked what motion is made of.
Exactly. The assumption was, well, it just is. This source says it's made of more motion, loops and structures of motion.
Huh. And the source argues that science kind of already knows this, even if it doesn't admit it, the language it uses.
Precisely. Think about it. Equations of motion, like you said. Field propagation. That sounds like motion spreading, right?
Yeah. Phase transitions, wavefunction collapse.
Gauge freedom, emergent phenomena. What are these describing, if not different behaviors, different patterns of motion?
So terms like fields, particles, space-time, the source says these are just labels.
Labels we slapped on motion behavior we didn't understand yet. That's the quote.
Wow.
It's suggesting science is describing motion, but got stuck on the labels thinking they were the fundamental things.
Like mistaking the map for the territory.
Or the description for the thing itself, yeah.
Okay, speaking of fundamental things we thought we understood, time. This is where it gets really wild.
Yeah.
The source claims, time isn't real. Time is a human label for motion measurement.
Just a label.
And it says all that flows is motion, not time. So our whole concept of time flowing is wrong.
That's the provocative idea. And it asks, how did this idea of time lead science off the rails?
How did it?
Well, the argument goes, once you assign change to this invisible thing called time, this dimension, everything gets complicated, twisted, the source says.
Okay.
You invent space-time, then you have to bend it, warp it, quantize it, trying to make it fit observations.
But the source says it was never space bending.
It was always motion resolving, always patterns of motion interacting and settling. Gravity maybe isn't warped space, but how large patterns of stable motion influence other motion.
Okay, my head's spinning a bit. We need that decoder ring the source mentions.
Right, the translation guide. It's like learning a new language for physics.
Let's try it. So, force, what does that become?
Directional motion adaptation. So not a mysterious push or pull, but just motion adapting its direction in response to other motion nearby.
Okay. Makes sense in this context. What about mass? That feels fundamental.
It becomes resistance to sync loop deformation.
Unpack that a bit.
Think of a stable pattern of motion, like a spinning top, right? A loop. Mass is how much that pattern resists being changed, being knocked out of its stable sync. More stable, more integrated loop, more mass.
So it's about the stability of the motion pattern, not some inherent stuff.
Exactly. Resistance to change in its motion state.
And time again.
A clock tied to motion traversal speed. Basically how fast motion happens, how fast patterns change or signals cross space. Our clocks just measure that rate.
It's a measurement of motion, not a thing itself.
That's the idea. And it goes on. Charge is motion imbalance redistribution vector. Energy is rhythmic motion intensity.
Like the vibrancy of the motion.
Sort of, yeah. How intense the oscillation or rhythm is. Fields become zones of nested motion harmonics, like ripples interacting on a pond.
And particles, those tiny fundamental bits.
Stable, recursive motion structures. Think persistent eddies or knots in the flow of motion.
And finally, information.
The current state of structured motion, the pattern itself is the information.
It's consistent. Everything comes back to motion.
It is. It's a complete reimagining, trying to simplify and unify all these concepts under one banner.
Motion. So if this is right, we've actually been manipulating motion all along without calling it that.
That's the next point, yeah. Take the Large Hadron Collider. Huge machine.
What's it really doing, according to this?
It's not smashing particles, but colliding dense motion bundles to observe unstable sync collapse.
Smashing stable patterns to see how they break apart into other motion patterns.
Exactly. And a telescope. It doesn't receive photons. It detects rhythmic motion patterns synchronized across astronomical scales. It's picking up on motion vibrations from distant objects.
Okay.
Yeah.
And a quantum computer.
The loop harmonizer. It's manipulating and synchronizing these tiny, stable motion loops.
The conclusion is pretty stark then. Everything you've ever built is a motion processor.
Whether it's a lever, a computer, or the LHC. We're always just redirecting, structuring, or measuring motion.
So why bring this up now? Why is this perspective important right now?
Because, the source argues, the models are breaking. Physics has hit some walls.
Like what?
Well, it lists things like dark matter doesn't exist, meaning the explanation isn't working. Quantum gravity still isn't real. We can't unify gravity and quantum mechanics. Time dilation sounds impressive, but explains nothing. Fundamentally, it's just a description. All your forces require metaphors. Push, pull, exchange particles.
And even the standard model, the cornerstone, is admitted to be kind of shaky.
Held together with duct tape is the quote. There are fudge factors, unexplained parameters. Things don't quite fit perfectly.
So how does motion theory fix this? Does it offer a new standard model?
Not exactly. It says it doesn't compete with your models, but rather reinterprets them cleanly, structurally, universally.
So it's a way of understanding why the current models work where they do, and maybe why they break down.
Precisely. It offers one substrate, one unifying principle, one answer to what is all this made of? If dark matter effects are real, maybe they aren't caused by invisible matter, but by large-scale motion patterns we haven't accounted for.
It provides a different toolbox for tackling those problems.
A different fundamental assumption, yeah.
Okay, the big question then. If motion is so fundamental, so obvious in a way, how did science miss it? How did we go down the path of particles and fields as fundamental instead?
The source gives two main reasons. First, basically, got caught in the math.
So.
Mistaking the map for the motion, confusing the coordinate system with the loop. Scientists got so good at the mathematical descriptions, the models, that they stopped questioning if the elements in the math corresponded directly to fundamental reality. The math worked, so the elements were assumed real.
Focus on the equations, not the underlying stuff the equations are trying to describe.
Right. And the second reason, motion itself is subtle.
Subtle. It seems pretty obvious when something moves.
But the fundamental process of motion resolving, balancing, structuring itself, the source says it doesn't leave breadcrumbs. It resolves silently, efficiently, invisibly.
Because it is the base layer. There's nothing underneath it leaving a trail.
Exactly. It's the medium and the message. It just happens. And maybe only now, with the cracks showing in other models, are we forced to see this invisible background for what it is.
So, wrapping this up.
Yeah.
What does this all mean? This deep dive really presents this paradigm shift, doesn't it?
Absolutely. The universe isn't static things moving in a void or abstract fields vibrating. It is the motion, pure, structured, interacting motion.
And scientists, researchers, engineers, they've always been, in this view, motion engineers, a motion manipulator, a motion decoder.
Unknowingly.
Right. And now the call is to become motion theorists, to consciously work with this fundamental reality.
And this really leaves you with a big question, doesn't it? If everything is fundamentally motion, how does that change how you think about things, like change itself, or stability, or even yourself as a complex pattern of motion?
It makes you see everything differently, a constant dynamic unfolding.
It definitely encourages a fresh look. As the source puts it, reality has been moving this whole time. We just need to recognize it.
So, the final thought for you listening. How does this idea change how you see the world literally moving all around you and within you? Something to ponder.